Feeling like taking a coffee break? So do I. How many times have you thought about leaving aside the readability of your code to preserve the performances? What about we just talk about that, improving your code using the Java 17 new features, especially records, on real use cases and see what it gives for performances. If you still think that writing readable code means giving up on performances, well, maybe you can watch the following. You know that measuring is always better than guessing, right? So let us check that out. Several days ago, Donald Drab, a good friend of mine, blogged about some katas he created and that he solved with the Eclipse collection framework. Donald is in fact the creator of this project, which is awesome, by the way. If you never heard about Eclipse collections, you should definitely check it out. So what's the deal? Well, there is a text written in a text block and 3 katas to solve on it. Don wrote some very elegant code with Eclipse collections, and the challenge is to do the same with the JDK 17. By the way, the text is a set of haikus that he wrote, which are also very nice, so you may want to check them too. We have 3 katas to go through with 1 myth in each of them that we're going to bust. So let us move to the IDE. The first kata consists in finding all the letters used in a text. The pattern you may use with Eclipse collections is this one, which is very nice. Now the question is, how can you write this with the JDK? Well, in the JDK we have this chars method directly on the string class that create a stream of all the characters that are used in this string of character. We can filter all the characters that are not letters with this method, and then map this to lowercase just to do the same as done. And then when we have that, what we need to do is to concatenate all these characters into one string of character. So for that we first need to pass from a stream of integers primitive type to a stream of strings of character. So we have a call to map to object that will do that, and then character.toString, which is a method added in the JDK 11 that takes a code point and make it a string of character. And now we can call our good friend the collectors.joining to create this string of character. Which one of the 2 patterns is the most readable? Well, I would admit that Eclipse collections does a slightly better job than the JDK, mostly because there is this technical call to map to object in the middle of this pattern, which is a little weird. How do they compare performance-wise? Well, there is also a slight advantage to Eclipse collections by about 30%. So if you think that readability and performances are not compatible, well, maybe you can think again. Fine, let us move on to the second kata, which consists in finding the 3 most frequent letters from the text. Here's the pattern using Eclipse collections. Now, this top occurrences method is very handy, and you don't have it in the Stream API, but it still needs some explanations. What it gives you is a list of pair objects that carry the char and the number of times it appears in the text as an int. In case of a tie, all the elements of the tie are added to the list. So if you call top occurrences of 3, which is the case here, and you have a tie for, let's say, the second place, you will in fact get 4 pairs in the list. How can you do this with the Stream API? Well, what you need to do is to build the histogram of the letters, and that's a job for your good old friend, the grouping by collector. You can first create a stream of character, or put in strings, just as you did in the first kata. And by the way, I have just copy-pasted the code from the first kata here. Let me get rid of this and call collectors.groupingby here as a collector. What you need to pass is a classifier, and here you just want to regroup the letters by themselves. So the classifier is just the function.identity. And then what you need to do is to count the different elements, that is called the collectors.counting, which will do exactly that. Now, what you have built here is a map of string of characters, each string holding one particular letter of the original string of characters, and the number of times each letter appears in that string in a long. So this is the map you have built. If you need to further process this histogram, most of the time, what you can do is stream its key value pairs with this entrySet.stream pattern. And from that, you can do basically whatever you want. Now, what you need to think about is that the stream you now have is a stream of key value pair, that is of map entry of string and longs. So if, for instance, you want to get the most frequent letter seen in the original string of characters, what you need to do is call this max method and passing the comparator map entry dot comparing by value because you want to compare by the longs. And of course, this max method returns an optional. So to open this optional, what you need to do is call the or else throw method on it. And what you get is a map entry of the same type of the map you had in the first place. This is your entry. And this is the most frequent letter. Now, what you need to understand is that this only returns one max. If there is a tie, well, you'd only get one of the maxes, which is not great. But here, what we want is not exactly that. What we want is the three best elements. So how can you do that? Well, you can still stream the entry set of this map. And this time, we're going to sort this stream with the same comparator as previously, but in the reversed order. That is, with the most frequent letters at the top. And what you need to get are the three best elements. So you can do that by just calling limit 3, and then, for instance, put the result in a list. So what you have now is a list of map entry and string of longs. I'm just going to copy paste this, and these are the most frequent letters. Now the compiler is a little lost with the types, so we need to tell him that what he has really are map entries of string and long, and that should fix it. And again, this will work, but only if you do not have any tie in this list. For instance, if you have two letters that are second, you will not get the third letter, you will only get the first and the 2 seconds. Okay, so that's the second time that this tie problem is in our way, so now we need to solve this problem. When you have a histogram like this one and you need to get several maxes by value, and you may have ties among these values, the best way to solve this problem is in fact to invert this map, regrouping the key value pairs by value and putting the keys that have the same values in a list. And this is what you are going to see. Let us go back to the IDE and take a look at this histogram. What we want to do is to invert this histogram, that is, stream it with this entry set, and collect it again with the collector grouping by, using the values as a classifier. So map.entry get value. And now what we have is a map. The keys are the values of the previous map, which is a long, and the values are lists because we didn't give any downstream collector, so they are lists of the elements of the stream we just created, which are map entry of characters and longs. And this is our new map. Now, we are not really interested in this map, especially because the value is not the value we want. The value we want is just a list of characters. So what we can do is pass a downstream collector, which is going to map this entry just to its key and collect the result in a list. And now the map we get is just a map of long. We have mapped this to the key of this map entry, so we just removed the value. And by the way, this is a method reference, so we can just write it in that way. And now we have a map on which we can extract a max using the key instead of the value from the previous map. And in case of a tie, we will have several values in our list. At this point, if what you need to do is extract the max of this histogram, what you can write is map.entrySet.stream takes the max comparing by key, open the optional you get with this or else throw, and now what you get is a map entry of this type. So I'm just going to copy this, add this dot entry there, and this is the most seen letter of the original string. If what you need to have is the top occurrences, the pattern is almost the same. What you need is just sort the stream in the descending order. So this time I'm going to pass the comparator dot reversed order as a parameter to this comparing by key and put the result in the list. And now what you have is a list of this element, and I'm going to call it most seen letters. So with this pattern, you solve the tie problem we had in the previous pattern. Of course, it's more complicated, but at least you have a correct solution. So, of course, the complete pattern with the Stream API is slightly more complex than the Eclipse collections want, just because we do not have the right method to solve our problem. But it also produces a result that is probably more accurate. If you remove the map inversion part, it becomes much simpler, but assumes that you do not have any tie in your histogram. In that case, performance-wise, things are quite close with a little advantage to Eclipse collections. Now, if you decide to invert the map, then you can see that the performance hit is quite small, less than 25%. Now, the real question is, can this code be improved? Because here we have technical code, you create maps, you play with entries, you play with collectors, and the business meaning of your code is just lost in all this. Your best move to improve the readability of this kind of code is to use meaningful variable names, and much better, meaningful type names. And to achieve that, starting with the JDK 16, you have records. Instead of working with a stream of strings or characters and thinking that these strings of characters are only one character because they in fact represent letters, let us map this to a stream of letters, because what you are dealing with are letters. And for that, what you need is a record letter. So let us play with that. So let me create this record, call it letter. It is going to be created on an int, because this is what I have in my original stream. I'm going to create here a letter record directly. I'm going to make that a var, because I will not have any problem with the type. And by the way, this character to lowercase can also be moved directly to the constructor of this record. So let me write this in that way. This is the canonical constructor of this record, and I'm going to say that this code point is not directly this code point, but the character dot to lowercase of this code point. And now I can get rid of this. So now what I have is a map of letter and long, which is better, which is more readable. But I would like to go one step further and create another record, letter count. The component of this record will be a long. And instead of keeping here this collectors.counting, I'm going to say that, okay, this is a collector.counting, and once this counting has been computed, I'm going to wrap it in a letter count. And now what I have here is a map of letter and letter count. I know that my histogram is built on letter and that I am counting the letters. The price to pay is just the creation of two very simple records as local records defined directly within this method. Now, how can I go one step further? Of course, this code does not compile anymore, I need to refactor it. But what I really would like to have here on this map is a map of letter count and list of letter, something like that. Letter count and list of letter. So of course, what I can do is keep this code as is because it's just work. I have the right map and the code I wrote will work with any kind of type of map. But I don't want to do that. What I would like to do is give again some meaningful value to this map. Here I have a stream of map entry, and the map entry is once again a technical object. I want to get rid of this technical object, and I'm going to make it another record that I'm going to call letter by count. So let me create this letter by count. This is a record, and the two components of this record are a letter and a letter count that I'm going to call count. Now for this code to compile, I need another constructor. So let me create this constructor, letter by count, that takes a map entry as a parameter, map entry of letter and letter count. I'm going to call it entry. And this constructor needs to call the canonical constructor of my record. And for that, I'm going to call entry.getKey and entry.getValue. So now the classifier is not mapEntry.getValue, which is once again purely technical code. This is letter by count, and I want to regroup by count, which is this. And the collectors.mapping is not mapEntry.getKey. Once again, technical code, it's letter by count, letter. So now my code is explaining me that I am creating an histogram with the letter count as a key and the list of letters that have this count as a value. How am I going to analyze this histogram? Here I have two analyses. First, a max extraction, and second, a sorting. To analyze this histogram, I am going to follow the same pattern as the one we just created. So instead of manipulating a stream of map entry, etc., I'm going to manipulate a stream, not letter by count this time, but letters by count, because I may have several letters. The components of this record are going to be the components of this map here. So it's a letter count and list of letter. So letter count and list of letters, let me call that letters. So now the constructor that I need takes a map entry, map.entry of letter count and list of letter. This is my entry. I need to call the canonical constructor with entry.getKey and entry.getValue. I'm going to put this in a var because the type is going to change. And I can follow this pattern to create the right comparator that I need to pass to this max method. So saying that letters by count should be compared by count. Let me create this comparator and return comparator comparing by letter by count, column count. And for this to work, this letter count should be comparable. So I'm going to go back to this record, implements comparable of letter count, add the right method. And since letter count is created on a long, I can return long.compare this.count of the .count. This is how I should be comparing letter count. So now I have this most seen letter, which is just the letters by count. I can do the same for the last pattern. These are the most seen letters. I'm going to map this stream using the same pattern, going to sort with the same comparator. By the way, I need to reverse it, put this in a toList, and now what I have is a list of letters by count with all the ties I wanted to have. So what I would like to show you is that by using records in several key points of your code, you can much improve the readability of your code. And better readability makes your code easier to maintain in the long run. But now we created lots of records, you may be wondering, performance must be absolutely awful. So what about performances? What is the cost of creating and using all these records performance-wise? Once again, the principle is measure, don't guess. The price to pay for readability in this case is about 10%. So I'm not going to tell you that it's free, nothing is free, but really it's super low. In that case, it's in the order of the microseconds. So if you're running this kind of code in a microservice that is accessing the networks, it's probably close to nothing. Right, the last kata we are going to solve has a new problem to see and a new myth to bust. This time it consists in finding the letters that appear only once in a text and all the others. It turns out that Eclipse Collections has a method for that, so it's just a matter of calling that method, which makes the pattern super simple and super easy to read. There are two ways to do that with the Stream API. So let us take our map from the previous kata as a starting point. I just modified the letter record a little bit to add a validation rule in it, and I also added a static method in the letter count record to put this ugly collector in it. So what does it give in the code? The first histogram, that is now called letters by number, is just this code, which is really very readable. Now, getting the duplicates and getting the unique letters from this histogram is really super simple, it's just this code. I just added two methods, is not unique and is unique on the letter by count record to make things even easier. But now what you may be thinking about is that you need two passes on the data to get this result. And you may be thinking, oh, two passes over the data, that must be a huge performance hit. Couldn't we find a way to do it in one pass only and then improve the performances? Well, sure, what you're doing is just a partition of your data. And we all know that there is a collector for that. And you can write this code in this way. You can call these collectors.partitioning by, passing the predicate that we just used in the previous pattern, and then map the result to get letter instead of letter by count. And what you get is a map of Boolean and letters. The unique letters are bound to the true key and the duplicates to the false key. Has the readability really improved? The problem is that you cannot wrap this Boolean in a meaningful record directly because it doesn't have much business meaning, so it has to stay there and there is nothing much you can do about it. And because of that, I think that the previous pattern is more readable than the previous one. Now the question is, what about the performances? Well, here they are. So yes, there is a difference. Computing two things with two passes over your data does not always mean multiplying your computing time by 2. Again, nothing is free, but is this tiny difference worth giving up on readability? Well, I'm not going to answer this question for you. You have the answer because you know your application and your problems better than I do. I really like doing katas. I think it's a great way to improve your coding skills. So thank you, Don, for sending them in. And if you want to see more live coding or if you have some katas you want me to try, please just send them in. And with this, I'm out of coffee. So that's it for today. Talk to you soon.